Thank you for tuning in. Today's video is going to cover linear equations. This is kind of like an accelerated explanation of what these things are. So we've got linear equations. Linear refers to straight line. An equation obviously refers to two expressions that equal each other. So linear equations are equations that model some sort of straight line if you were to graph it. And there are there's two forms that you'll see linear equations in. You'll see them in standard form, which is ax plus by equals c. And x and y represent two quantities. So this is kind of a new change because we've got now two variables, x and y. Rather than just having one variable, we've got two variables. So we've got something that represents two quantities. In standard form, you might see like 5x plus 6 or 7y equals negative 13. So this is an equation in standard form here. The second type of equation that you'll see is in slope-intercept form. So slope-intercept form, this equation is pretty much what it sounds like. This is what we use to graph. So we can tell a lot of things about a line on a graph if it's in slope-intercept form. And slope-intercept form is y equals slope, which is mx, plus the intercept, which is b. So we've got y equals mx plus b. And we can tell things about our line based on it being in slope-intercept form. Well, we know that y and x, these are values, x and y, that are coordinate points. These are solutions to the line. So if we plugged in two numbers, like 5 and 3, plugging in 5 for x and 3 for y, and we'd simplify it, and it comes back with the same number on both sides of the equation, something like 3 equals 3. Then we know, okay, 5 comma 3 is a solution to this equation. M, which is the slope, and slope is the rise over the run. And B, which is the y-intercept. So a little bit about these two things, y-intercept and slope. Slope is the rise over the run, and the slope compares the change in the y variable over the change in the x variable. So when you rise, you change in the y, right? And when you run, you change in the x. So we have, some sort of graph here, x and y, and then when we have this line, we're measuring, okay, how much did the line change from here to here? We measure the rise, and then we measure the run. Okay, so this is our slope. In the real world, slope is called average rate, some sort of average rate of change. The y-intercept. So the y-intercept is where our line, so if we look at this little graph right here, crosses the y-axis. In the real world, the y-intercept is considered to be the start value or the starting value of the two quantities that you're comparing. So the starting value of your dependent quantity, obviously. So starting value, and this is always a constant. So let's look at an example. So we've got an example here. Maybe we have y equals 5x plus 10, where we're comparing two quantities, and the quantity x represents time, and the quantity y represents distance. So we're representing the distance that we've gone versus the amount of time that we've gone a certain distance. And here we have two quantities, and one of the quantities is dependent on the other. So y is always going to depend on x. This is important to understand that the relationship is independent and dependent. So the change in y is caused by the change in x. So here we have 5 is the slope, and 10, which is our constant being added, is our y-intercept. I know that 5 is the slope because 5 is being multiplied. And if 5 is being multiplied, that means it's some sort of rate. Rates get multiplied, like $5 per hour. You would multiply 5 times the number of hours, right? In this case, 5 miles per hour times the number of hours, which is our time, right? So let's say we want to know the total distance that we've gone. If we're going 5 miles an hour and we started 10 miles from home, how far are we from our house? So we'd figure it out. Okay, we've gone 3 hours, so we'd say we're going 5 miles an hour times 3 hours, plus we started 10 miles away from our house. How far are we away from our house? Well, 5 times 3, we've gone 15 miles, 15 miles, plus 10 miles equals 25 miles. We're 25 miles away from our house. So we have our slope, we have our y-intercept, and then 3 would represent the x value, and 25 would represent the y value. So this would be a solution to this equation.